Thank you for those of you who have joined. It looks like some of our familiar faces, and I look forward to being able to share this topic with you. All right. I appreciate all of you who were being very patient. So let me start off by introducing who I am. I am on the teacher advisory board for the NEED project, so I'm one of the NEED teachers. My name is Samantha Danielli, and I am a teacher in Virginia. I teach pre-K through 5 science lab, but I have taught the older grades as well, so it's certainly a lot of fun to be with you here today. Though my students are on spring break, I will certainly share this video with them. Hopefully they'll join live today, but if not, I'll share it with them as well later. Our goal today is for us to take a look at what is a little bit below the Earth's surface, the crust. So the title of today's activity is What Lies Beneath. A fun little play on the activity that we're going to do about core sampling. So I have a little show and tell for you first. This is a way to take a core sample, but if you're a geologist, this would not suffice. This is only 1 foot, but it works for the demonstration purposes. So again, this can take a core sample for about 12 inches, or as I said, 1 foot. And let me go ahead and show you a few different core samples, and then I'll explain why would geologists or scientists, engineers, petroleum engineers want to take a core sample. So just a second, let me show you the core samples I took earlier today. So here in this pan, we can see that there's a couple different core samples. We have a core sample over here that is, really dark. And then we have one here that's a little dark on top. Actually, it might work better for me just to reverse it. Okay, sorry. So we have one that's quite dark at the top, and then it shades and fades out a little bit. We have one here that is dark, but not as much here, and then it fades out as well. Here we have one that is very sandy, actually. So if I pick it up, it just falls right between my fingers, and I'll explain that in just a second. But then it does have a little bit of a dark coloration down here, as well as we have a core sample that broke apart just a little bit, but we can see that this is very much more of that orangey color. And this one I had hit a root, so I was not able to take a full foot core sample. So here we see several different examples, and this was just in my neighborhood. But just by taking a look at this, the scientists can explain, even if they were not here at the same location, a little bit about the soil. So for instance, these two were taken right below where there was a group of trees. And we know that because of the organic matter at the top. Where this one over here was taken at the angle of a slope. And we can tell that not much of the organic matter had a chance to decompose and build up. And this area here actually was over by a construction site. So we see that it was a lot of loose topsoil that had sort of built up at this whole section here. So this is just a very small sample of what a core sample is. So a core sample can be used for a variety of reasons. Oh, sorry, there we go. A core sample can be used by geologists to take a look anywhere from a meter down to about 200 meters into the ground, so they can see what lies beneath. By taking a look at the different layers of the material whenever they pull out their core sample to take a look at, they can tell by the material, the amount of pores in the area down in the core sample, whether it would be an ideal location for them to take a look for some of our energy sources that we're looking for, gas, petroleum, that sort of thing. Other scientists might be interested to take a core sample such as near volcanic activity. So it can also tell us a lot about history. So by taking a core sample out in the area where there's a volcano, what that allows them to do is by taking a look at several different layers, if there was a layer and then that same coloration would repeat itself in certain volcanoes, by knowing what type of ash that volcano would spew, if they would see that layer of ash and then there was some soil and darker area, then they knew that there was a lake or a pond that had built up. And then if they saw that ash again, they would that core sample would indicate that at that time period the volcano erupted again. So I just wanted to share with you a little bit about that history, and I'll explain some more as we go. But here are some of the materials that we need for our activity. You need an opaque cup, so a cup that you cannot see through. So I have two different examples, a waxy one, a white small one. If you have a little bit larger one, that works too. We don't need to take that large of a cup in order to have our example of a core sample. Other materials that you need are different colors of sand. This is regular, play sand, some topsoil. Now these colored sand pieces I actually got at Michael's a while ago, so you can get colored sand as decoration pieces. If you do not have colored sand, let me show you what I used for this core sample. This is aquarium rock. This is white sugar, light brown sugar. I used coconut sugar next, but you could use brown sugar. And then on the top, instead of using soil, this is chia seeds. So you can be creative with the materials that you have in your house if you don't have access to sand, or you can repeat this activity later on when you do have the ability to get the different colors of sand, because the sand will work quite nice along with using our water spray bottle. And then I also have some of the aquarium rock. Now, if you don't have any access to a spray bottle or an opaque cup or any of the sand, here's an example of something that you can do if you have the ability with your family at home. You can make core sample cupcakes. I'm not able to do this in a school setting because of food restrictions, but what's fun about the cupcakes is as you pour them layer by layer, you won't know until it's baked what it would really look like. So it's really fun, and I even had a mini lesson with my husband and my daughter last night. And so these core samples are really pretty fun, because up on the top I have coconut and chia seeds as my topsoil and the organic layer. If I cut into this, so you see that you don't even have to use a straw for this one, because honestly, straws are really hard to come by these days. In my house, I use steel straws, and so I had to go sort of on a search to find where I could find a clear straw. But we'll use a clear straw for our activity in just a second. But this one, the cupcake, I was able to cut into it, and notice how we have a large area here where it dips down of this darker area, but we know, I told you the top was our topsoil. So here this shows us that some of that organic matter, as it rained, it started to leach down those nutrients. And we see that this is a little bit lighter brown. So we see that it's a little bit more water filled and it leaches down. But then here we even see that maybe we found a rock, or this could represent some of the minerals, and or even you found a coal patch. So you could be very creative at home with how you are doing your different core samples. And this, I used a larger muffin tin. And you see that this one was in a very different location because it was mostly this dark area. And then there's a little bit of the leached out area below. Now this one here, I would say would probably be represented of a sandy area because it's mostly just light color well, there's the dark here, but then there's the rest of the light color. So it's not as dark overall as these with the grass and things like that. So again, it's a lot of fun to be creative with how you want to do it. But let's dive into today's activity of the core sampling. So what you're going to do is take your opaque cup, and you are going to start off with about 1 centimeter. So 1 centimeter, you can take a look at your ruler, is on the side that has the numbers closer together. That sometimes can be confusing whether you're using the metric system or the English standard units, but we're using metric because in science we do use the metric system. So 1 centimeter is really about the width of my finger. Okay, so you can see that it's just a little bit smaller than the width of the finger, or the depth of the finger, okay? So if you're doing it that way, you can sort of have your finger amount. So let me move our yummy core sample cupcakes out of the way and bring closer the materials that we need. We have our rocks and our light color sand, our dark color sand, our soil. Okay, so first off, you're going to use your spoon to spoon in about 1 centimeter of earth material. The reason why we want to have the opaque cup is because you want to make sure that you are having that unknown image. You don't want to already know what it's going to look like, otherwise it's not the same resemblance and model of a core sample. It's not like we can do what I just did and take a look inside of the earth like this. We actually have to take a sample out. Okay, so we put in, okay, our 1 centimeter. We can see that I put it to about the height of my finger. Okay, the next step you need to do is spritz it with some water. So we spritz it with some water so that way the layers sort of adhere together a little bit. Okay, so next up I'm going to put in some more earth material. As you saw with the cupcakes, you might not have to have it exactly like your neighbor. So if you and your sibling, or you and your mom and dad are doing this, or a classmate, maybe yours might have this color for all of this width here, but maybe just a little extra. And so that can represent maybe that area is a little, a bit different section, or a different part of the country than somewhere else. Because we know some states have a lot of natural gas reserves, but not all states do. So this core sampling allows us to represent how each location is slightly different. Spritz, spritz, spritz. Now it could just be 1 spritz. I went ahead and did 2 because the first one I sort of sprayed outside the area. So we see that it's just a little damp, and next I'm going to do my next layer. Basically the goal is we are going to get 4 centimeters high. If you want to pre-mark your cup with a line of 4 centimeters, that works. Or you can just eyeball it, using your, finger 1, 2, 3, 4. So I'll go to about here. Okay, so let me add in this layer here. So I'm doing some of the darker color. So the reason why I'm doing this darker color next is because in this example for me, this is going to represent the A horizon, or what the A horizon is basically is our topsoil. But then right above the topsoil is the O layer, which is the organic matter, the material that has started to break down. Organic matter is something that's alive or has recently been alive, and as it breaks down, decomposes, it then becomes part of the soil. Okay, so now we have our 4 layers. Now, just as an example, I did one earlier, and you can see actually to help me out, I had pre-marked 1 centimeter at a time, and then I went up to 4 centimeters. Just for fun, we'll do one more, but this time I won't put the bedrock. I will start with the other ones first. So I'll do a little spritz at the bottom just for my interest here. I'll put in our 1 centimeter. Okay, and don't forget to spritz in between. Sand particles allow water to sort of seep through. So if you put too much water, then the water is going to start to soak on through down to the bottom. So we don't want to overfill with the water. Just need to put enough for it to kind of get a little sticky. You know, just enough to where if you kind of balled it together, it'd stick together. But since water seeps through sand, it's not like you can actually form a full ball out of it. Okay, so I'm going to do spritz, spritz. Next, I'll put in my other color here. This is kind of a fun fuchsia color, not necessarily earth tones, but it allows us to have an idea of a different layer. So as I said, you can be as creative as you need to at home. You could try with the sugars in the home, but those naturally, because of the stickiness, will stick together quite a bit more. So the core sampling might be a little bit different experience, but it doesn't hurt to give it a try. So I have 3 examples. If you're doing this, what you would do is after you make yours, you then trade it with your neighbor, and so then you don't know what it looks like. So with this straw, you don't have to have it as long as it is. You can even cut it in half and share with a neighbor. What you're going to do is you're going to create a vacuum seal, and once you've stuck it down in there. Okay, so I'm going to pierce the straw down all the way to the bottom. Kind of jiggle it just a little bit to make sure it gets down there. Then you will put your finger on top. By creating that little vacuum seal, you should be able to hold it all inside. So in this case, some of it, that bottom layer did fall out, but then we do see that there's a large amount of blue and then a small amount of the organic layer on top. Okay, so that's a fun version. You can shake it out and you can try it again. So I've kind of shook it out. I now can try either in that same one in a different part, or I can try in a different one. There we go. Gotten down to the bottom, put your finger on top. So I did drop that last part out, but we can see how it's at a nice angle here. And the angles could certainly represent what actually happens in real life, because in some of the areas of the country, you might have a younger shale, as well as a mixture of silt and sand, which can create these different layers. Because what happens is, let me shake that out. And you can see it in my example here, how depending on where it is, some of the other material starts to seep down into that parent material. These rocks here represent the parent material, but then if you look here, I have got some of that bedrock example. Okay, so you can see how it's not always just pure straight lines. I can go through a few of these examples again if you'd like, but let me pause for a second. I know I've been talking quite quickly. I sort of get excited and then need to remember to slow down. Are there any questions that are coming through? I can pause for a second to make sure that we are not running past any of the ideas. So one of the reasons why I love this activity is because, one, soils, people overlook all the time, but soil can be super important not only for the geologist perspective and from the energy perspective of finding out what's beneath, 200 meters, 300 meters, even down to 1,000 meters to see what sort of material we can find, including are we going to find a pocket of natural gas. But also, people such as farmers or construction workers are going to need to know what the material is in the ground. And so they'll take, again, longer than just a 12-inch or 1-foot core sample, but they'll need to take a core sample to find out what sort of nutrients are here. So if a farmer finds out that there's not enough nitrogen in that area, then they know that they need to supplement the nitrogen in some way, whether it's in a particular organic way or if they're going to spray the field to supplement the nitrogen. Or that will tell them, you know what, this year I'm going to need to make sure I have a plant that is nitrogen fixing to fix the form of nitrogen it can get from the soil to use in the plant. So they'll learn from this information that they'll take from their core sample as to what sort of crops they can have. Do they need to rotate between? So even though we're not even that close, meaning myself, but depends on where you are in the country, to a farm itself, it does affect us and our food supply. Or as I said, with construction purposes, one of the samples I showed you here, this one, as I pick it up, you can see it just like falls right out and I can feel it's grainy. And so if there is a lot of sand, then are we going to be able to build a tall structure on sand unless if we have reinforced it and made sure that we've accounted for that? Because otherwise over time, maybe it will shift. So there's lots of great questions that you can ask yourself as to whether this is going to affect you in your life. I know that sometimes I'll tell my students as they're cutting the corner from a sidewalk to a sidewalk, no, don't do that, because what you're doing when you stomp on the soil is you're losing out on some of those air holes, the pores in there, and so then the water won't be able to get stored inside of the earth, but instead if there's no air holes, the water's just going to sit on top and we might have flooding issues. So there's all sorts of different reasons why we want to know what's down underneath the earth. But let's see. Oh, about septic systems. So where I grew up in the country, in a small town south of Springfield, Illinois, and we had a septic system. We weren't close enough. But even sometimes in the areas of cities where it's better for that particular neighborhood to use a septic system. So the septic system does have a similar working to a water quality plant, a water treatment plant, in the steps that it takes in order to filter out and clean the water before it kind of goes out into the ditch. But what you're asking about taking a core sample, I would need to look a little bit more into that. I mean, that is not my area of expertise, but that's certainly a possibility, and I would expect that they would certainly need to take a core sample in order to know how deep to put the material as well. But that's a great question as to what they're looking for in that core sample. I'm sure that what they want to know is how far out is the piping and having the water trickle under the ground. How far can they go? It also has to do with, if you're doing a septic system, the water table as well. So there's a lot of factors involved. Any other questions that we can answer? Again, I'm sorry I didn't have a complete answer for that, but that definitely inspires me to look a little bit further into that information. So again, to replicate this at home, you just need a couple different colors of sand, a little topsoil, some aquarium rocks to represent your bedrock or your parent material at the bottom, some opaque cups, a straw, so that way whenever you take your sample and get it down in there and pull it on up, you're able to take a look at what it looks like. And that represents what a core sampler or a coring device looks like. But again, this is a very small example. And you can also use materials you might find in the house. Or you can go the fun route like I did, the edible way of taking a cupcake. And just for fun, I'll take my clean straw here and see if I can take a core sample from inside of this cupcake using the straw. Okay, so I'm going to take my, there we go, got all the way down to the bottom. I'll pull it up and looks like it did make a hole, but it didn't pull it up as much as it did with the sand. But it can be a lot of fun for you to try out a few different things. Also, maybe if you have a wider diameter, that might affect whether you're able to pull it up as well. So it looks like that's all for today, and certainly please hop on and share this with other people so that way students, families, remember that you can always be practicing and exploring science from your own backyard. Even if you didn't realize that there's so much beneath that grassy and dark topsoil layer. Thank you. Have a great afternoon.